So now I'll explain what we're going to be doing here. So the symbol for chi-square is like a goofy looking X squared. So we have to find our degrees of freedom next. So I'll find my degrees of freedom, and I do that by looking at the number of rows minus 1 times the number of columns minus 1. So up here we see that we've got 2 rows minus 1 times the number of columns, got 2 minus 1. So 2 minus 1 is 1, 2 minus 1 is 1, so 1 times 1 is equal to 1. I have 1 degree of freedom. So I'll take a look at my degrees of freedom chart, and you have one in the back of your book. I will load one onto your homework for you, but this is the chi distribution table, and what we're looking for is we're going to have an alpha level, and there's the alpha level of 0.05. And what that means is that our distribution is going to be somewhat positively skewed. It's going to look something like this. I've got a mean of 0, and I'm going to come all the way down here and look for 5%. So I have an alpha level that's equal to 0.05. 5% of this distribution is going to be my critical value, and that's what I'm trying to find. So I have 1 degree of freedom here with an alpha level of 0.05. So I'll find my alpha level, and it's going to be 0.05 right there. And I have 1 degree of freedom, so I'm going to match those two up, and I get a critical value of 3.841. 3.841 standard deviations from that mean of 0. And that's going to include, beyond this particular critical value, is going to be 5% of my distribution. And that's going to tell me if my score, my chi-square obtained score, is at or beyond this critical level and falls into the 5%, I will know that my observed and my expected scores are statistically different from one another, and that they're not the same. So that's what we're trying to do. So let's take a look at the statistic. And the statistic says that I have to sum all of my observed minus my expected, and I'm squaring that, and I'm going to divide it by my expected values. So we're going to take, and here's what the numbers look like. I'm going to take, for the first cell, my observed, which is 47. I'm going to subtract my expected, which is 33.55. I'm going to square that, and then I'm going to divide by my expected, 33.55. And I'm going to do that for each one of these cells. And so as I've done the math, and I've done it in steps, so you can see, and you can do this along with me if you'd like, and I came all the way over here to a chi-square value of 23.16. So when I do that, I plug that 23.16. Is that a greater number than 3.841? And it is. So I can reject the notion that the observed and the expected values are the same. And I will reject the null hypothesis. And I will accept the notion that there are statistically significant differences between my observed and my expected values. So that's kind of how that works. So I'll come back over here, and like I say, you can follow along with what I've done on the board. And I'm going to take these values here, like I say, and I will, you just break it down. I'll subtract this, square it, and then divide by my expected value. And then over here, I'll take this number, I'll square it, but I'll still divide. And then once I've divided, then I just add those up and come to my obtained chi-square value. So that should get you through. It's not difficult, and this is going to be the same type. The numbers are going to be different, but the situation is going to be the same. I'm going to give you data that's very similar to this, and it'll be aggression, non-aggression, and we'll have a null hypothesis, a alternative hypothesis. The only thing that you're not going to get a value on is going to be your p-value. And the p-value is a probability of making a type 1 error. So in this particular statistic, what I want you to submit is that p, and that's this one, yours may not, but you'll find out once you determine if your chi-square obtained is larger than the critical value. So the probability for making a type 1 error, a type 1 error, remember, is rejecting the null hypothesis when the null hypothesis was actually true. And when I set my alpha level, I'm saying that there is a 5% probability that that's going to happen anyway, with a critical value of 3.841. Now the higher, I should say lower that number is, no, higher the number, the lower the probability will be. So you're just going to report that the probability for making a type 1 error is less than 0.05%. Or you can just say is less than 5%. And that will work. Hope this video is helpful, and look forward to grading all your homework.